Well, good evening, and here are your notes on continental drift and Pangaea. Now, continental drift is a theory that states that the continents were once a single landmass that broke apart and drifted to their current location. This theory was proposed by Alfred Wegener. Alfred Wegener was a German meteorologist, so the W is pronounced like a V, Wegener. Now, he proposed that the continents were drifting, and so with that, he stated that at one time all of the land masses joined together, making one huge continent, and that was Pangaea. So Pangaea, by definition, is a single landmass that existed 245 million years ago, MYA. Now, he did have a lot of evidence for the existence of Pangaea. First of all, he began looking at the shapes of the continents, and he saw that quite a few of the continents fit together kind of like a puzzle, that the shapes lended themselves to be put together. When they were put together, he noticed some very interesting things. One, that mountain ranges lined up. So that would be mountain ranges that were in South America, North America, Africa, and Europe. He also saw the reptile fossil remains of the Mesosaurus. And these fossil remains were found in South America and in Africa. Now, this was important because where South America and Africa are fitting together today, that reptile could not possibly live on both of those continents with a vast ocean between them. They could not have swam from one continent to another. So they must have had a single habitat, where if you put South America and Africa together as they would fit, you would find that those two areas would come together. If you look at the map below, you can see the purple area is coded for the Mesosaurus, and the curve of South America would fit nicely up against the southern part of Africa. Now, a third clue is the Glossophorus fern. If you look on the map, you will see that the tropical plant fern was once found in Antarctica. Now, that is interesting for two reasons. If you put the continents together, as Wegener thought that they existed and they were put together, you would see that the green area would all come together like a big band, a stripe, indicating that that plant also had a common environment. And also, because Antarctica could not grow tropical ferns today, then the land that is now Antarctica must have been much closer to the equator in order for this tropical plant to grow. Well, it's not there now, so it must have moved. The continental drift theory was not accepted during Wegener's time because he could not explain how the continents would move. So how are the continents moving? Well, we know that they are now because we are now aware of seafloor spreading. Wegener didn't know this in his day. We didn't learn about seafloor spreading until we started looking at the ocean floor, and we didn't do that until the 1960s. But what we saw when we got down to the ocean floor was what you see in this picture here, and this is seafloor spreading. In this picture, we see a representation of two oceanic plates that are pulling apart. Magma is rising through the gap in the middle of this break, Now when the magma comes out, it cools and it forms new sea floor. Now this process is continuing, and we have evidence that it is continuing. Now this helps to show that the continents that were connected together, this happened in the middle of that connection, in the middle of Pangaea, and broke Pangaea apart. And we can see this break in the ocean floor today. It's known as the mid-ocean ridge, and it's in the Atlantic Ocean between North and South America and Europe and Africa. So what is the evidence that seafloor spreading is happening? Because not only do we need to know that it happened then, but we can see that it is continuing to happen now. We find that the newest rock, brand new rock that is being made when they date the rock, the newest rock is at the mid-ocean ridge. Well, that makes sense because that's where the rock is being made. If you look in the little picture down below, you can see the break between the two arrows, the magma coming up and cooling, and that's where the new rock would be. Now, the other thing that they found about rock ages is that the rock got older and older the further away you got from the ridge. So the oldest rock then was found at the edge of the oceanic floor, which would be at the trenches where it gets pushed back down into the mantle. We'll talk about that in a little more detail later. So as they tested the rock age away from the mid-ocean ridge, let's say they tested it 100 miles in either direction, it would be older and about the same age. And then they would go out 200 miles from the ridge. In each direction, the rock would be about the same age and even older than at 100. At 300 miles, it would be even older and the same age on either side of the ridge. So as the arrow indicates there, and you can kind of see the stripes that are on the ocean floor, could represent also the age. So the further away you get from the mid-ocean ridge, the older the rock is. Now there was another very interesting occurrence also that they discovered, and that was the magnetic reversal. There's iron in rock. We've learned that before. Well, the iron in the rock, when that molten rock, let me go through and explain how this happens. When the molten rock is coming up at the mid-ocean ridge, it's a liquid. And the iron, as it starts to cool and solidify, is magnetic. And it will line up like a compass does, to the needle of a compass, to indicate where the north is. Now when that magma then cools and solidifies, and that becomes a rock, the iron is always and forever lined up in the direction to indicate where the North Pole was. So there's evidence that's held in the rock there. Now what they've discovered is that the polarity has reversed. Sometimes it was north and sometimes it was south. And so they saw in the picture, if you look here in the picture, the light blue stripes indicate normal polarity, or to the north, and the dark blue stripes represent when iron in the rock indicated that the polar direction was to the south. The magnetic pole was to the south. And we see that it has switched many times, at least 9 times throughout the history of the ocean floor. And they find it very much the same from one side of the mid-ocean ridge to the other side of the mid-ocean ridge. That would indicate that the ocean floor is being made at about the same rate and being pushed away from the mid-ocean ridge in both directions. Now we will do a model both of Pangaea this week and of the seafloor spreading, and code it with the evidence. So that's it. Those are all the notes you have to take right now. Bring those notes to class on Monday, and we will continue with this information. Have a great weekend.